Hey everyone, how's it going? This is Siri and I'm back with another PyTorch video for you guys. And in this video, we are going to move on from talking about tensors, how they work, to, diving a little bit into how we use those tensors and how we use the things that we've learned so far to work with different types of data. And you all know that the main idea behind machine learning and behind deep learning is the fact that you can take an input, you can apply a series of computations on it and operations on it, and, get like a desired output. Okay? And these computations you can kind of have a general idea depending on what components you decide to use in your complicated mathematical web. And the whole web is just for the sake of the model to, learn the relationships between the different parts of the input, different parts of the output, so that next time when you have a new piece of data, you can easily get the fact that this input corresponds to this particular output. And so, what you should all know is that inputs and outputs, like whatever I'm talking about here, regardless of what you whether the inputs and outputs are images, tabular data, or whatever else you want it or need it to be. Okay, so if you're starting out with an input image, or like an input value or an input that is an image, and you want to know whether it's a dog or a cat or something else, then the image would be your input, and that classification of whether it's a dog or a cat would be the output. But the thing is, you can't pass in just that regular image that we can see. We need to, because like the whole training process and the whole mathematical web, which we call a neural network, is based on math, right? It can't multiply images, like it can't multiply, this red part of the image with this green part. It needs to know how we represent that red part and that green part or whatever in numbers, so it can perform the operations that we've learned in our previous videos with tensors, right? So we need to convert that image into a form that our model can understand. And we're not going to be talking about models yet. That's going to be in our neural networks video or some other video. But here we're just going to be talking about how we work with images, how we represent them, what we can do with them, how do we load them, how do we normalize the data. And I think that's pretty much all we're going to get to in this video. And maybe we could talk about volumetric data because it's pretty similar to what we have here. So what is an image? Well, you all know what an image is, but you might be familiar with the idea that, we have different pixels in our image. So our image is basically just a bunch of pixels. So, like if you have this grid, you can imagine this grid. You must have seen one. If not, I would definitely recommend checking or looking it up, right? So, maybe you have a smiley face, but that's your picture. But you have a grid that, overlaps with it, and you can see the different parts of the image. You can see the different, what color is this cube, what color is that cube, how all the pixels together make up the overall image. Right? So machine learning sees these images as pixels. That's all they are. That's all an image is to a model. and we need a way to work with it, and work with images. We're actually going to be talking about other forms of data, like I said, in the next series of videos of, like I said, tabular data, time series, and like text data and other things too. But we're talking about images in this video, and so images are just a bunch of pixels, like I said. And how do we know that this particular pixel is like purple? Or how do we know that this pixel is like yellow or green or, you know, a certain color? Well, there's a number associated with that color. And what we have as a final like product of our conversion from an image to like tensors, basically, like that's the way we represent images. We represent images using tensors, and that's the numerical format that I was talking about. And so each pixel gets associated with a certain value, and this value, like probably between like 0 to 255, if we're talking about RBG, which just stands for red, blue, and green. If we're talking about those color channels, then you know, you would actually, let's just stick with gray. Each pixel would get a value telling you that, hey, this pixel is this shade of gray, this pixel is black, this pixel is white, this pixel is another shade of gray. Okay, and the computer knows that, and the model knows that, depending on the number that you that the pixel is, right? So for grayscale images, there's one value associated with each pixel. Okay, there can be multiple values associated with a pixel, and each one of those values, they're probably actually they're most likely like different attributes, and they tell the model different features or characteristics of the image. Not the entire image, actually, like we're just focusing on that one pixel. So yeah, so for example, what do I mean by you can have multiple values per pixel? Well, I mean, if you have an RBG image, which is just a color image, you actually have three values associated with each pixel. Okay, so what do these three pixels tell you? Well, one tells you how much red there is, how much blue there is, how much green there is. And so you must have seen in art or, you know, just in general, that each color is made up of certain amounts of like a few basic colors. And what those colors are may vary, although it's often like, you know, the primary colors, right? But actually this one's RBG instead of the yellow. So it tells you how much red is in this pixel, how much blue is in this pixel, how much green is in this pixel. And based on these three values, you get a unique color. And so if you have a series or like a collection of pixels, different pixels that tell you what each pixel's color is, then you get an entire image. And so maybe you can have other features too, not just color. Maybe you can, like, maybe if we had a depth camera, then one feature would be the depth, right? And the colors. Maybe for another example, we could have temperature, right? Or density. We could have so many different, you know, values that tell you a different facet of that pixel. Okay, so yeah, So we each, like I said again, each pixel would have 3. If it was just a regular color image and we took it with a regular camera, it would have 3 values associated with it, 3 scalar values, which just means they're just regular numbers. And in regular cameras, the scalars are often just 8-bit integers. But for other applications where things get more complicated, like this, like what I said here, temperature, density, maybe you had like some medical imaging that we were dealing with, and you might need more precision if you want to make like better predictions, maybe, right? So maybe like that could change. So the 8-bit, the integer could, become a 32-bit or something like that, right? With more precision. So let's talk about loading an image file. And what I'm going to do here is I'm going to be using image.io, and you might be wondering why. Because Torch Vision seems like a perfectly alright tool and library to use to load these images. And I completely agree. I agree 100%. And honestly, I would too. But for the purposes of this video and future videos, since we're not only going to be dealing with images, which is what Torch Vision, get it, computer vision, that's what it mainly deals with. Just for the sake of consistency, I want to use like the same tool to load different types of data. And for that reason, I'm going to be using image.io. But if I was just dealing with images and I was just dealing with one problem and I want to solve it, like when I say problem, I mean like a different project, right? If I was dealing with another, just a project, I was just focusing on that project, I would use Torch Vision. Okay, so let's import Torch, right? After all, this is a PyTorch video, and it's like a series of PyTorch videos. Let's import Torch, but let's also import image.io. And let's create an image array, and let's set it equal to image.io.read. Okay, and well, not just image.io.read, but I downloaded an image which I called bobby.jpg, and it's an image of a dog. So it's in the same spot where this Jupyter notebook is, so I don't need to actually specify the path because it's in the same spot. But if it wasn't, then you would have to, pass in the path here. So yeah, let's run it. Okay, great. Okay, so if you've watched my previous videos, or if you just know, we can convert between NumPy arrays and PyTorch tensors. That's an easy conversion, and that's what, honestly, a part of what makes PyTorch so great. So the way this is gonna go is first we're gonna, read the image. Then we're going to convert it to a NumPy array. And then third, we're going to convert it to a PyTorch tensor. Okay, and so when let's import NumPy as np, and let's say num array is equal, I might as well just say NumPy. Okay, so it's equal to np.array. So what this does is that it just converts whatever we pass in to a NumPy array if it's possible. So we do that, and it's great. And so now we check the type of NumPy array, and NumPy ND array. And so now, since we already imported Torch, let's create a real image. Okay, torch.fromNumPy. So so pass in numpy array. So what this does is from a numpy array, it'll convert it to a regular PyTorch tensor. So that's what it's doing here. Oh, I did read instead of I am read. Okay, so that's where all the problems are coming from. Don't worry, it's okay. So, okay, this is just a markdown. Thank goodness. Okay, so we don't need to do any of this nonsense. Import numpy is np, numpy array is equal to np.array, image, okay, run, thank goodness. Okay, finally we're getting a regular numpy array. So now it's, okay, it's an int 8. And now when we run it, we get no problems, okay? And so, okay, so what we did was we did, okay, let's comment this out. Okay, once again, we read the image. And so the IM made the whole difference, because what this does is that it actually takes that image and converts it to like a matrix-like format, which was the numpy array, and now we can, you know, convert it to a tensor. Okay, so if you take a look at the type of image, we finally get torch.tensor. Okay, okay, so now let's talk about how we would, you know, put it into the model. So would we do it one at a time? Now, if you remember from a previous video, we don't do that because it's a waste of resources, right? We already, actually it's not a waste, it's like literally you're not using it. So if you have so many like things that are able to process your data and you just do it one at a time, you're not making use of the computational resources that you have. Whereas if you pass them all in at once, that's not good either, right? So what we do instead is that we pass them in batches, which is just a few samples, or however many is, you know, suitable at a time. So usually it's like 32, but for our case, let's just stick with like a few. So if you remember from like our video on initializing and creating tensors, you know that dot zeros and dot ones is a good way, right? So so we would use that, and actually another dimension is not only your color channels. This is a dimension. Did I forget to mention that? Okay, so we have an image and we have certain dimensions, right? So we usually just have a height and a width, right? But if it's color, actually even if it's not color, if it's not color, then we would just pass in 1. But if it's color, then we would pass in 3, letting the model know, hey, like there are going to be 3 values associated with each pixel in the image. So there are 3 color channels. So 3 color. There are 3 color channels. Okay? But now that we added in this batch, right? You need to tell the model, how many samples are you giving me at once? Well, I'm going to give you however many I want, and that number is going to be the batch size. Okay, let the batch size be 3 for now. Just a few, right? So, okay, so what this is it's the batch size. It's the color channel. How many color channels are there? And the height and the width. Okay? And So let's do something here. Let's import torch. Let's create a batch size real quick. 3. And let's say batch is equal to some batch. Okay. Yeah, batch. Okay. Batch is equal to torch dot zeros. Okay, we're just initializing it with zeros. Okay, so batch size, like I said. Batch size is now a variable that's set equal to 3. Okay, there are going to be 3 color channels because Bobby's not black and white and gray. And 256 by 256. So these are how many pixels there are along along both the height and the width. Okay? And let's just set the d type, which is the type of the values in the tensor, equal to torch.u int 8, because that's the, see here, the numpy array d type that's storing our image. Okay? And you know, let's run this. And let's import OS. Let's say our data directory. So maybe I gave the wrong impression that we're actually still working with Bobby. Which I thought we were actually, but I forgot we have a batch size and Bobby's only 1 image. So what I have instead for you guys is a data set, or just, you know, like like 3 images actually, which is why our batch size is 3. So we have 3 images. Let's call that our, you know, data set. And they're images of cats. Sorry, Bobby. So let's, okay, so now we're dealing with cats. Jumping so quickly from cats to dogs. So now we're dealing with cats. I downloaded this. You should too if you want to code along. Just search up images of cats and probably take 3, since that's our batch size. If we had like hundreds and thousands, maybe like our batch size would be like, maybe not hundreds and thousands, but maybe thousands. Our batch size would probably be like 32 or 64 or something like that. Right? So our batch size is often, you know, smaller than our actual data set. But in this case, we're just using 3 images, which is why I wanted to import OS. Okay, so dir. Okay, so it's not really a path because it's in the same spot, and I like to have things in the same spot actually. It just makes the code a little bit easier. So now let's have image file names. Okay, let's use some list comprehension here. So let's say that name, for name in list os.list directory, we pass in our data. Okay. If the os.path.split text name, we'll go through this in a second, don't worry. So it's like an if statement inside the list comprehension. This is the last element. If it's equal to .png. And actually everything in my thing is .png. So like if you had like other CSV files maybe, then you would do this, right? So so let's do some loop here. So for I in file name, image file names, file name, in image file names, we're in enumerate image file names. So we're going through each one. We're also going through, we're going through each one. And we are saying image array is equal to image.io.im read, don't forget that. os.path.join, data directory, file name, actually image file name. Okay, I'll go through this once we're done writing it. See if you can piece together what's going on while I'm typing. What I forgot to do here was image.permute. And what that does is it puts the dimensions in the right order. So image.permute, and let's say 201. It just tells you the order in which you want your dimensions. So you want, we're using the same storage instance here. And if you want a refresher, or if you want to check out what storage instances are, feel free to check out my video on storage instances. So any change here made to the image, it's going to show up because it's the same storage instance. So now we're using the order of dimensions we want, which is the color channel, height, and width. If it's in any other form, like height and then channel and then width, it's not going to take it. So so what did we do here? We said 201. So 2, probably the color channel was last. 2, and then 0. Zero should go in second. So probably height was 0, right? And the other option is width. Okay. So that's probably how it was, right? Height and width and the color channel at the end, but we want it to be height and width, and then the color channel needs to be in the front. So that's what permute does. It just changes the order of the dimensions. And this is particularly relevant, especially when you are rendering your data and when you're actually visualizing it. And so Matplotlib usually takes in your image or whatever you want to display in a certain order, and .permute really works well in that kind of situation. Okay, so yeah, so we got sidetracked for a bit. Okay, .permute, same thing, 201. Image t is equal to image t, and then we're just taking everything up until 3. So batch I is equal to image t. So this is the batch. We're saying I. This is like, you know, you're indexing through the thing, and you're going to do it 3 times because we have 3 images of cats. And essentially what we're doing is, you know, we're just, first of all, we're reading in the image, and we're doing the same thing as we did before. We do the from NumPy, we change up the order of the dimensions, and we are actually setting each image. We're adding each image to this, and so we get a total batch at the end, like a batch I. Okay, so that's what's going on there. Let's talk about normalization. And you can have your batch is equal to like a float. Okay, you're just turning it into a float, and we can divide by 255. That's an option, because what normalization does is that it scales down your values to between 0 and 1. Scales values down from 0 to 1. So if all of your pixel values are in between 255, between 0 and 255, if you divide by 255 for each one, then you're gonna get a value between 0 and 1. So that's that. Another option is you can say that your number of channels is the first dimension of your batch. I mean the second dimension of your batch, because the batch size is the first one. Okay, let's make this in a code cell. So 1, and so for C in range of the color channels. So for basically every color channel, we have a red, we have a green, and we have a blue, or maybe the blue comes first. So think of it as like different layers of the image. So you have an image which can be equated to a red layer of the image, and a blue layer of the image, and a green layer of the image, and think of it as like stacked up on top of each other. Yeah, that's a good way to think about it. So if going through each of those like little sheets of your image, you can set the mean equal to torch.mean, and then batch, and then everything up until the color channel, actually of the color channel, and STD, which is just your standard deviation, which just tells you how spread apart your data is with respect to the average, and you would basically do the same thing. Okay, and batch C is equal to batch that minus mean. This is just regular slicing, whatever I'm doing here, Python slicing. So if you're kind of confused about that, I would recommend like searching that up and getting familiar with that. So mean, and then we're going to divide by the STD, just to keep things uniform throughout. Yeah, so that's another option for normalization. And the reason we do this is to keep things normal with your gradient and your optimization part of the training. But we'll get into all that later. Okay, actually we don't have time for volumetric data today, or at least in this video. We'll talk about them in another video. They're going to be pretty similar to images, and I'm looking forward to seeing you then. Thank you so much, and don't forget to like, comment, and subscribe.